Yes, to section 3.4, linear functions. Our objective today is to recognize linear functions and use tables and equations to graph them. Let's start with our vocabulary. A linear function is a function whose points lie on a straight line when the function is graphed. So basically, it makes a line. Discrete data is data that involve a count of items, such as number of people or cars. We plot them and connect with a dashed line. Continuous data is data where numbers between any two data values have meaning. So basically, we ask ourselves, can you have parts of the things in the function? If yes, you use a solid line to represent it. Note that things can be discrete and continuous. We can count things and it can be continuous. How do I know if a function is linear? If I look at a table, if the ratios between the changes in variables in a table are the same, then the function is linear. On a graph, if the graph forms a straight line, it is linear. Let's look at these tables. Let's decide if they are linear. So I look at these. Let's look at the changes. So this goes up by 1. It's a plus 1. This goes up by 1. This goes up by 1. The y's are going up by 2, plus 2, and then a plus 4. So we look at the ratios. So we're going to take our y's over our x's. So it's always got to be y over x. So I have a plus 2 over a plus 1. I have a plus 2 over a plus 1. And for the third set, I have a plus 4 over a plus 1. Well, 2 over 1 equals 2 over 1, but that is not equal to 4 over 1. So this is not linear. Let's look at function 2. From 2 to 1 is minus 1. 1 to negative 1 is minus 2. And negative 1 to negative 4 is minus 3. Along the y's, I have a plus 3, I have a plus 6, and I have a plus 9. Let's see if these ratios are equal. 3 over negative 1, 6 over negative 2, and 9 over negative 3. Well, when I rewrite these, 3 over negative 1 is negative 3, 6 over negative 2 is negative 3, and 9 over negative 3 reduces to negative 3. These are all equal, so that one will be linear. So try this one. Decide if this one is linear or nonlinear. Let's look at this. 5 to 9 is a plus 4. 9 to 17 is a plus 8. And 17 to 21 is plus 4. Negative 12 to negative 13 is a minus 1. Negative 13 to negative 15 is a minus 2. Negative 15 to negative 16 is a negative 1. So our ratios are negative 1 over 4, negative 2 over 8, and negative 1 over 4. Well, negative 2 over 8 simplifies to negative 1 over 4. So these are all equal, which means that my answer is linear. Let's look at a graphing situation. A gallon of milk costs $2.59. The total cost of G gallons of milk is a function of the price of 1 gallon. Make a table and graph the function. First, we're going to ask ourselves, is it discrete? Can I count gallons of milk and price? Yes, it is. It is discrete. Is it continuous? Can I buy a quarter gallon of milk? No, they don't sell those. So this one is not continuous, which means when we graph it, we're going to graph it with a dashed line since it is discrete and not continuous. Let's make a table. We're going to have gallons of milk, and let's say C for cost. So 1 gallon of milk will cost me $2.59. 2 gallons of milk would then cost me $5.18 because 2.59 plus 2.59. For 3 gallons of milk, it's going to cost me $7.77. And for 4 gallons of milk, it will cost me $10.36. Now we're going to graph it. Along the bottom, we're going to have gallons. Along the side, we will have price. Let's skip lines on the gallons. So 1, 2, 3, 4. And for price, let's make every line worth $1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, when I graph this, I have 1, 259, so it's going to be about there. I have 2, 518, so that's about there. 3, 777, about there. And 4, 1036, which is about here. This is mostly linear, depending on how accurate I was. So I make this with a dashed line. Draw my arrows on the end, and there's our graph. So you're going to try this one. The function c equals 15t represents the cost in dollars of t adult tickets to a museum. Make a table and graph the function. First, think about, is it discrete and is it continuous? So our answer is it discrete? Yes, it is. I can count it. Is it continuous? No, I cannot buy half of a ticket to the museum. When I make my table, T and C, let's say I use 1, 2, 3, 4. 1 lines up with 15, 2 is 30, 3 is 45, 4 is 60. When we graph, we should have number of tickets along the bottom and costs along the side. Let's skip a line on this one. 1, 2, 3, 4. And for cost, let's go up by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, hundreds way up here. Now let's graph it. 115 is about there. 230 is right there. 345 is right there. 460 right there. I'll connect with a dashed line since it's discrete and not continuous. Here's example 3. Eric lifted weights and burned 100 calories. Then he walked and burned 257 calories per hour. The function c equals 257h plus 100 gives the total calories Eric burned, where c represents calories and h represents hours walking. We're going to use this equation to make a table and a graph of the function. First of all, is it discrete? Can I count both things? Yes, I can count both things, calories and hours. Is it continuous? Well, yes, he could work out for a quarter of an hour, that's fine. So let's make our table. Remember, being continuous means that I'll graph it with a straight line. So we have hours as our inputs, calories as our outputs. Let's do 1, 2, 3, 4 as usual. If he works out for 1 hour, 257 times 1 plus 100 will give us 357. If he works out for 2 hours, 257 times 2 plus 100 gives us 614. If he works out for 3 hours, 257 times 3 plus 100 makes 871. And if he works out for 4 hours, 257 times 4 plus 100 gives us 1,128. So on our graph, along the bottom we'll have hours, and the side will be calories. Let's skip lines on our hours, 2, 3, 4. And for calories, let's make each line worth 100. So 1, 2, 3, 4, 500, 6, 7, 8, 9, 1,000. All right. 1 goes with 357. So 1, 2, 357. 2 goes with 614. So about there. 3 goes with 871. Maybe there. 4 goes with 1,128. Oops, I missed a little bit. So it's going to be about here. I connect those with a solid line. You'll notice for this one, it's not going through the origin. That's okay, it might not always. So you're going to try this one. The function a equals 4,000 minus 600m gives the altitude of a plane in feet after m minutes. Make a table and graph the function. First, think about, is it discrete and is it continuous? So our first question, is it discrete? Yes, I can count both of these things. Is it continuous? Yes, I can plug in a quarter of a minute. That's fine. When we make our table, m is the input, a is the altitude. For m, we'll plug in 1, 2, 3, 4 as usual. Our altitude for 1 is 3,400. Remember, 4,000 minus 600 times 1. Our altitude for 2 is 2,800. For 3, it's 2,200. And for 4 is 1,600. So when we graph this, we'll have time at the bottom. We should label that that is in minutes. And we'll have altitude for our y-axis, and that's in feet. Let's skip lines along the bottom. And for altitude, let's make each line worth 300. So we'll have 300, 600, 900, 1,200, 1,500, 1,800, 2,100, on and on and on. So our graph should plot 1, 3,400, which should be right about here. 2, 2,800, which will be right about there. 3, 2,200, probably about here, here. And 4, 1,600, about there. This is a solid line, so we connect our dots as best we can. And there's our graph. Here is your assignment. We will have a quiz following them.